Welcome to another video. This is a continuation of the Shem-Prashad lead code series that we're currently going through. This video will be looking at the subtree of another tree algorithm. The link to the Shem-Prashad list will be in the description, and also the link to the lead code will also be in the description. So let's get to it. So we are told that we are given the roots of two binary trees called root and subroot, and we are to return true if there is a presence of root with the same structure and node values of subroot, and false otherwise. So if the root and the sub, if there is a subroot of that in the root, okay. A subtree of a binary tree is a tree that consists of a node in 3 and all these nodes descendants. The tree could be considered as a subtree of itself, okay. So if what they mean by this last statement is, if for example we had this exact 3 4 5 1 2 in the same order as the subroot, that's also a subtree of itself. So that will return true, basically, is what they are saying there. So but here we see that 4 1 2 exists as a subroot here, so it's fine. But here 0 is not in this descendant here, so this is not a subroot, okay. And we're told that for each of them there will be at least one node. There will be at least one node, okay. All right, so let's get to the board and see how we can put this together. So here we have, so this is subtree because by the time it goes searching, when it gets to this 2, it finds 2 and 2 and it says okay. It finds 4 and 4, it says okay. It finds 5 and 5 and it sends, and there's no more children. And since it found every exact data of this in each other, it means that they are the same. It's a child. So basically it means that we could use the checking, for example, when we solve the algorithm to check if two trees are the same. I think we can use that same logic here, where we check that if the node is the same with the left and the right is also the same. I think that will work for that. But we need to keep, so both, that's on one side, but on the other end is that we need to go through our tree to look for where we find the value in the root where we want to start searching. So for example, we will be asking the first node here, 1, is not the same as the content there, is not the same as the content here, which is 2. So if you come here, the content here is the same as the content here, so we want to start searching from here. So that's the point. So I think that is okay. I am seeing that what if we have a scenario where, for example, we have 2 2 2 2 2. So for example, and let's say the node we just want is something like 2 2 2 2. So you know, by the time it checks at this point, it will say this is not a child, because by the time it checks this is fine, but it sees that this has children and this doesn't have children, so this definitely is not a subtree. So but we don't want to stop there. We want to come and check this other 2 and see, and you know, when we check this other 2, we see that this actually is subtree. So that's what we'll be doing. Okay, so that means although we will check for 2, we don't stop at the first place where we find it. We keep checking, we go through, so that is 2 iterations or through 2 traversals. The first traversal is we are looking for where we find the value of our subroot, whatever is at the root of it, where we find that value. That is one transversal. The second transversal is when we get to that point where we find the match, we want to now start checking if from that point on it's the same exactly. So that's 2 traversals. So the first is to check for the item in the subroot, yes, to see if it's actually anywhere we find the value there. So for example, we find the value here, So when we find the value here, we now begin to check. We check each pair, we check each pair, we check each pair, and we see that it doesn't have this, so we say that is false, and then we come to the next one again. This is a match, another match, and we do the same thing here. So that is an approach I'm thinking we could use. Let's get to it and see it. So let me create my method. Do I want it to be a, yeah, I think I can make do of a bool returning it exactly the same. So that will be DFS, tree node root, and then tree node subroot. So basically, what I want to achieve with this, I want to keep going through until I find where I have a match, right? Okay, so what we could do is if the root is null, then we know we don't want that. Okay, but we also know that if it's null, it's null. Okay, but we also want to check, we're looking for where the root, the value is actually going to be equals to the subroot. We're actually looking for this, because when we have found this, where we have something like this, then we know that we can now go ahead to do our check. Okay, so it means I will need another for the check if same, and so passing the roots and the tree node. Okay, so this is when we now go ahead to perform our check. But if they are not the same, what do I want to achieve? Okay, so when they are not the same, I want to keep going through, and even if they are the same, I still want to go through, right? So, but if they are not the same, okay, so if they are the same, I want to go ahead and do this check if same, and I want to do roots. I want to pass in the root and the subroot if they are the same. So let me just have this value equals to false, so that I could just say value is equals to this. Okay, basically I just wanted to set a boolean, and okay, so if it comes true, that is when I can have my true there. So let's see. But okay, but irrespective of whether I find a match or not, I want to actually check the other nodes in case I find one. So okay, so what I could do is I could just say if I find value, then that's fine. If not, if this value is not okay, then I want to go ahead and check to is subtree DFS, and I want to check the root, the left, and I want to also check for the right. Subtree DFS, the root dot right subroot. So basically I want to check, go to the left in case it went and then it wasn't matching. Like for example, in this scenario, when it checked with these first two and it's found that it was a match at the beginning, but when it going through, it saw that it was not going to be a subroot of it. So in that case, we want to still go ahead, come here and do this. But if it finds it and it's a subroot, then this will be true, and then it will ignore all of this and return from that point. Okay, so but what we want to now do in the check, so what we just basically want to do is to check. So if our root is equals to null and our subroot is equals to null, we know that we are okay. So we want to return true. But if for whatever reason, if our root is equals to null or our subroot is equals to null, then I want to return false, because at this point I know that there is a mismatch. Either the root has more or the subroot has more data than the other, so definitely they are no more a match. And then I just want to check if the root value, if it's equals to the subroot value. And I also want to check for the children also on the left side and on the right side. So the right and then the subroot dot right. And I also want to do the same thing for the left. Check if same, and then the root dot left and subroot dot left. Yes. So basically, this is just going to check when I find a match, when I find where we have a subroot that's equals to the root, then from there I want to search, check if it's the same. And if it's the same, it gets here, it's true, and then it returns. But if it's not the same, then we go into the left and check if we can find a value that is actually the same as the subroot. If it goes through and it doesn't find it anywhere, it returns false. So the reason I'm using false here is because I want to use, if it is true, I want to use the or. And you know, or with a true, that is the, so when this is true, that is the only time my data here will come out to be true. So if not, it will return back as false. And so I could just return is subtree DFS and the subroot. And I think this is good to go. Let's run it and see. So okay, only assignment call is increment. Oh, I did not return, so return false. Okay, so return false. Let's run this again. Okay, so it seems good. Let's submit and let's see. Hopefully it passes. Yes, it does pass. So basically, we are just going to keep iterating or keep traversing the tree until we find where we get the value of what is in the subroot. And when we get those data, then we go ahead and check if it's the same. And if it's the same, then we return from there. If it's not the same, we keep going deeper into the tree. So this will be my solution for this. And if you have any question, please drop it in the comment section and I will respond. Thank you and see you in the next video.